Machining is a relentless hobby. Other than the countless hours it takes to become even slightly proficient in it, there always seems to be some tool you need that you don't have. And with endless options to pick from, finding the right one for the job can be an exercise in and of itself. And of course the prices of things can always put some tools just out of reach. So you make do, and you make do, and you make do, and you make do until you finally get that tool that solves all your problems. Okay, what's in the box? Well, I know, but I have some more unpacking to do. A nice gentleman named Nathan reached out after seeing some of my recent woes and offered to send along the solution. Gotta commend the packing job on this. So the big reveal? It's another box. But seriously, I haven't even opened it yet, and this is so cool. Just look at that patina. And these brass tags are freaking sweet. Really appeals to my love of all things old. Okay, enough yapping about some chipped paint. What the hell is in this box? Oh mama. This is a tool post grinder. More specifically, this is a Do More No. 5, also called the Master, and it was made, well, I don't know when. But just judging by the cool factor of this thing, I think it's from the 1950s. I mean, look at the beautiful design of the castings, and the paint looks like it was worn away long ago. But the embossed nameplate is still completely legible. They don't make things like this anymore. Just look at how beautiful this thing is. Okay, I keep repeating myself. I said this was a solution to all my problems, so what did I mean by that? Well, recently, I made a live center for my new lathe. And despite my best efforts to machine everything perfectly concentric, I still ended up with quite a bit of runout in the tip, making this more of a live knot center, which isn't very useful. And it turned out many of my other live centers have this same exact problem as well. That's where this tool comes in. This tool post grinder was designed to be used on the lathe, and as the name suggests, it mounts on the tool post. And as you'll see, I'll be able to use it for grinding the tips of my live center is perfectly true. But we'll get to that soon enough. We don't even know for sure that this thing works. So let's fire this bad boy up. Ha, it sounds like a jet engine spooling up. 15,500 RPM is no joke. Fortunately, no flames are coming out the back end. My feeler gauge indicates it's running in the right direction though, and I can tell it's drawing in the cooling air it needs. So we're off to a good start. Now how about that spindle? With this pulley combination, that should be somewhere around 6,000 RPM. Nothing exploded. Okay, I think that's enough for now. I haven't oiled anything yet, and I'd rather not burn this thing up before we even get started. Despite the worn paint, which I actually find quite charming, this thing seems to be in remarkable shape. Absolutely no rust, just a bunch of grime. So we're going to do what anyone who gets a new, used tool would do. Clean it. Now I'm not going to go too crazy here and tear this thing down to every nut and bolt. I just want to get the most offensive areas clean. And I'm definitely not going to be repainting this. Ha, what do you know? This thing is actually blue. Or sort of a gray blue. an appropriate machine tool color. I'm having a little trouble getting back in this area. It's going to bother me if I don't get this cleaned as well. I guess I could just take the motor off here real quick. But now I'm seeing how grungy the spring is too. And this bracket could use some spiffing up. And might as well slide the spindle out of here, which of course needs some disassembly. And some persuading. And some deburring. Well, that escalated quickly. At least now I can properly, truly get this thing clean. The spindle wipes down easy enough, but it's still looking a bit worse for wear. Lots of nicks and scratches. So let's pop this in the lathe and give it a good polish. Alright, bonehead alert. I only realized after the fact that using the live center on the central spindle like this was a bad idea. I don't think the bearings inside are intended to take axial loads like this, so fingers crossed I didn't just ruin the most important part of this tool. That polished up pretty nicely, but now these plier gouge marks are really bothering me. I don't think it'll hurt anything to take a few skim cuts to clear these up a bit. Not perfect, but definitely better. As is the rest of this. But there are some nooks and crannies that I just couldn't reach with my normal brushes. Luckily I have the perfect tool for getting in those deepest recesses with today's sponsor, Lumino. Normal brush strokes leave areas untouched, but the teeny tiny strokes of Lumino's ultrasonic toothbrush let the bristles do the work they were meant to. They wiggle their way into the hardest to reach places to remove plaque, machining grime, or whatever you might be holding a grudge against. Other electric toothbrushes do this as well, but can also attack your gums, your enamel, and generally your entire mouthhole region. So Lumino went with a less is more approach. The unique castor oil bristles combined with a moderate vibration of 36,000 pulses per minute mean this brush focuses on removing plaque from the tightest areas without making the rest of your mouth a casualty. With 5 modes and 3 intensity levels, it's easy to find the setting that suits you or whatever you might be cleaning. And the replaceable heads are made entirely from renewable materials, so you don't have to feel guilty about switching to a new one. In all seriousness, this is the first electric toothbrush I've ever used, and there's just no way I can go back. It literally feels like leaving the dentist's office, without someone sticking their hands in your mouth on a daily basis. Plus, it generally makes things more appetizing for my wife, so there's that. This feels really well built, there's an integrated pulse timer telling you when to move on, and it comes with a wireless charger so you never have to worry about a connector failing. I love this brush, and I think you will too. Use the Amazon link in this video's description and check this box to get $10 off your Lumino electric toothbrush and a speedy delivery. Thank you, Lumino, for making everything I do just a little bit cleaner. Okay, I think that's as far as my OCD is going to get me. Let's get this back together. Now I couldn't find a manual for this, but the lubrication points seem pretty self-explanatory. And considering this is a spindle, I'll use some, drumroll please, spindle oil. It looks like there's another port on this end of the body as well, but weirdly it's missing the same label. And that would be why. That's definitely something different. Actually, it kind of looks like an adjustment mechanism. Yeah, I think that's exactly what it is. I'm guessing this is for preloading the bearings inside. And if that's the case, this tells me these are angular contact bearings. So that little stunt on the lathe actually wasn't all that bad after all. Now I have no idea how tight these should be, but that much free play doesn't seem normal. So let's snug it up a bit. The spindle still runs pretty easily, and there's almost no play, so that must be about right. Oh, almost forgot to give these little cuties a squirt as well. Last piece is this bracket for mounting the belt cover, but I'm not sure that's going to fit well on my lathe, so we'll circle back on this. Speaking of fitting this on the lathe though, let's work on that now. The first obstacle here is getting the grinder's pivot to actually jive with my lathe's tool post. For one, I'm going to have to open this hole up a bit, but there's also a little shoulder at the base here that I need to clear as well. I want this large flange to sit flat on here so it's as rigid as possible. And now, from the rolling hills of rural Kentucky, we will hear the beautiful Morse Drill Concerto by Ludwig van Leithoven in the theme of cast iron. Ah, doesn't it just make your ears bleed with pleasure? Okay, enough of that. I won't be able to stand it if this next part is even just a little boring. This big one should help with that, though. This concerto is equally sanguinary. But then I realized I should be running this a lot faster for the carbide insert I'm using. Combine that with raising the tool a smidge, and now we're in business. For good measure to make everything square, I'll face the bottom, then cut that clearance recess. Okay, let's see how it fits. Seems like that did the trick. Just enough play to slide in place. The grinder plops down on here, and now we need a way to secure this. The tool post handle obviously isn't going to work, so let's make a trip to the crate of misfit lathe parts. Score. This is actually the original top nut from the tool post that I replaced with that handle, and it works perfectly for this new application. One of the few times in my life it actually paid to be a pack rat. Okay, we're on the lathe, but we're not done yet. Ideally, this grinder's center line should be at the same height as the lathes, and there's no chance we got that lucky right off the bat. Fortunately, I have the perfect tool for comparing. My tool height indicator. Since it's already zeroed at the lathe's centerline height, I can read what the top of the spindle shaft is, then just subtract my reading from the radius of the shaft to know how much it needs to come up. Easy peasy. But how would one do this if they didn't have this perfectly designed and crafted piece of tooling? Well, that's not so hard either. You can mount an indicator right on the cross slide and sweep the spindle underneath it, zeroing on the top. Then move over to a shaft the same size that's mounted in the chuck. And then the difference in the measurements is exactly how much we need to raise the grinder. Which, of course, is a different number than before. How could that be? Well, this is embarrassing. My height indicator's out of adjustment. I'll lock this down really good this time. Okay, so the tool post needs to come up, and the easiest way I can think to do this is to make a simple spacer ring for under the grinder. So that's exactly what we're going to do. Alright, let's get this in place. If I did everything correctly, this should read 0.187. And only 2 thou high. Wait, no, that's actually 98 thou low. What now? Ah, well, I done goofed. When I took my initial measurements, I didn't realize the casting was riding on the face of the base plate and not on the central boss. So that spacer I just made isn't even remotely the right thickness. Luckily I know just how much thicker it needs to be. Okay, how did this one turn out? Nice, only 6 thou high. I could try to find a way to mount this in the lathe again and skim a bit off the top, but I have a quicker option. Bingo. Okay, we've got the grinder on the lathe, and we've got it set to the right height, so we're ready to start grinding my live centers into shape, right? Well, yes, but also no. I need to come up with a way to spin a live center while I'm grinding it, and I'd really rather not stick my fingers in this particular meat grinder. So that's where these drawings come in. I know, I skipped the drafting table, but considering this is a side project, and side projects are supposed to be quick, I saved myself some time with the old confuser model, as my grandfather would say. I'll explain what's going on later, but for now, let's just get started. Luckily, I have just barely enough material to make these parts from. Going to plan nicely. Now let's poke some holes in it. If I'm being honest, these parts don't need to be as complicated as I made them. I really just wanted an excuse to play with my radius fixture. With this, I'll cut all the curvy bits, but I can't just plop this down here and go to town. They have to be in the right spot as well. So I made another perforated part that I'll use as a fixture. Pretty nice. Though I did realize I completely forgot a couple features that will be a lot easier to do while this thing is still mostly square. This pocket is part of the pivoting mechanism, and this threaded hole is for an adjustment screw. Pretty simple stuff. Back on the radius fixture, we can continue with the fanciness. A lot of this is basically the same as before, just with different locating setups, so just enjoy the chips. That's the first part down. Let's keep the wheels turning. Now I know you've been wondering all along what the point of this shorty hole here was all about. Well, it's nothing too profound, just a simple reference for where to stop this particular arc. Bada bing bada boom. Just a little more regular milling on this one. First skimming off the excess material from the bottom, which my camera didn't seem to care much about. Then setting each side up at an angle to cut the V-groove. Okay, there you have it. Two mildly overcomplicated parts to achieve a simple goal. But they aren't ready for their job yet. We still have a slew of other parts to make. Luckily, they're a lot simpler, and I get to use the lathe again. Woohoo! Now, I'm deviating from my plan slightly. I was going to make 2 of each of these bushings, but then it occurred to me that it would be a lot easier to combine them into a single design. This is actually one of the first lessons you learn as a design engineer. Fewer parts is always the fastest way to reduce cost and setup time. Next up is the spindle pulley doohickey, which also uses the more is less approach. I'll use this piece of A2 left over from some failed knurling attempts. I've found I can move through a part pretty quickly if I use a stouter insert like this for the heavy lifting. Then just switch to a polished insert for the final touches. Next is a circlip groove that I happen to have a solid carbide grooving tool for. Thanks, Craig. But I didn't quite think ahead on this one. With this sticking out this far with no support, this may not end so nicely. False alarm. That worked perfectly. And with that out of the way, we can take care of the most critical features of all. One more groove on here, but this one comes with a twist. So we're going to need a side project. Though I'm a bit puzzled on how to denote this one, being that we're already in the middle of another side project. Which, if we're being technical, is a side project for the Live Center to begin with. Which itself is a side project for the new lathe. Okay, I've confused myself. Let's just cut that groove. Hang on. I'll round this part out with some chamfers, a hole in this end, then a set screw hole over on the mill. I gotta say, these all turned out nicely. Bushings, the pulley shaftamajig, a pin, which I'm sure you can imagine how I made, and some hardware. Let's put it together. Well, doesn't that look fancy? Okay, maybe it's time I fill you in a bit about what's going on. You'll remember we made this whole contraption to drive the points of my live centers. So this thing actually clamps to the body of the live center with some hose clamps. It's not super pretty, but it's super simple, and I had to make up for the overcomplicatedness I threw into the rest of this contraption. I can run an O-ring belt around this pulley and then around, well, I guess I'm going to need another pulley down here, aren't I?
Nice. Beautiful. Wonderful. Oh, I love it.
Man, these donuts are killing me today. Admittedly, this one is all my fault. Why I thought I could skip the lubrication is beyond me. I'm sorry, buddy. It's been a good run. Let's do it right this time. Okay, I've got 3 pulleys here, each with slightly different bores for the 3 different live centers. The bores are actually a couple thou undersize, and that's what these splits are for. Tightening a set screw expands the pulley just enough to slip it in place. Then loosening that screw lets the pulley close up on the live center. The belt is tensioned with the set screw back here, leaving the final mystery of how I'm actually going to drive this thing. Well, this is the coolest part of it all. Because I'm going to use this. Some brake cable sheathing. And by clamping one end in here, and then the other end in the lathe chuck, boom, I'm driving the live center. There's a bit of elasticity built up in this setup, so hopefully that doesn't cause me any headaches. But still, not bad for a side project. Okay, let's get to the real project. Ultimately, I'm going to have to feed the grinder at a 30-degree angle, so to start, I'll set the compound to 0 degrees. Then get the grinder roughly straight with that as well. This old wheel is a little sus, as the kids say these days, so I treated myself to a bright and shiny new one. It still needs a little truing up first, though. Luckily, the grinder came with its original wheel dresser. I just need to make sure that the diamond tip is below the wheel center line, or this video could get really exciting really fast. Lastly, I'll cover absolutely everything I can. The last thing I want is a bunch of grinding grit getting lodged in my lathe wave, sending this machine to an early grave. Okay, let's do it. I'm feeding the wheel with the compound instead of the carriage to ensure that the grinding face ends up parallel to the compound's ways. So now when I rotate the compound 30 degrees, I know the wheel will be that as well. Now, finally, we can do some grinding. Heh, it's working. You can even see the runout that used to be in this tip. And it's all gone in a matter of a couple minutes. Man, hours and hours of work getting this tool all cleaned up, making a whole other tool, and a few side projects on top of that for a couple minutes of work. But I do have 3 live centers, so it's a little more justified. In all seriousness, it may seem silly to spend this amount of time chasing down a couple thousandths of an inch, but actually it's the exact opposite. The whole point of a precision tool is that it removes a source of error from your work. Make a faulty assumption that your live center is running true, and you just transfer its runout into the part you make with it. And when you make a lot of your own tools, that error ripples through all your other projects. Case in point, this live center I made was all wonky because the live center I used while making it was all wonky. But now, butter baby. So yeah, the time was well worth it. But I'm not hyping up this grinder enough. Beyond this little reconditioning project, this grinder has infinite uses, and it solves one of my biggest hurdles, grinding cylindrical parts. Popping this thing on my lathe basically turns it into a cylindrical grinding machine, without having to actually buy a big piece of equipment like a cylindrical grinding machine. But to be honest, I still want one of those too. Anyway, this tool post grinder is literally a game changer for me, and I can guarantee we're going to get a lot of use out of it. Thank you again, Nathan, for sending along this amazing tool, and to everyone else, thanks for watching, and see you next time.